Today, we're going to be working on activity 0402. We're going to go through the SkeeterSat assembly and operation manual. I'm going to be highlighting multiple parts of this, but the aim is for you to work on this individually. So please make sure that every student is going to assemble this by themselves and also do the testing by themselves. But for this activity, we're going to focus only on the assembly and operation part of it. In the end, this is what our board is going to look like. There's also going to be a thermistor coming off of here as well. But in general, this is what we're working towards. So this is what the completed board will look like whenever we get done. So just to go through the manual real quick, the first part of it, please read the description, the history about it. Very important is the theory of operation. So please go through this, as this is going to be very important for your report that you're going to have to do whenever you go through and test and calibrate it, as well as discuss the results in a report. So it's important that you read through this and understand it. And that way you can properly discuss how the circuit works. The materials for this, we're going to be soldering again. So we've talked a little bit about safety with soldering. It's again important in this activity. Please make sure you have safety glasses or goggles. You're going to have the SkeeterSat kit of components and circuit board. In the previous lesson, if you have not done the lesson A04.01, please go back and do that lesson, as that is going to go through the inventory of the SkeeterSat kit and all of those components. And I discuss all of the components in details. You need your multimeter. You need a soldering iron and solder station. You also want to, we've discussed this before, you want to have your sponge wet. So go and use the water fountain or whatever to wet that. It should definitely be wet. That's for the soldering iron. You'll need a 9-volt battery at the end. You need solder. And then we're going to use small tools such as the needle nose pliers, wire cutters, a hobby knife. Probably we can get by with just the things we have without using that. If you do have one, that's fine too. And I think 7 is optional for the adjustable DC power supply. So you don't necessarily need that for this activity. So your work area, you need to have a flat work table, and please make sure your area is clean. And I've talked about this previously, but you want to make sure that the surface you're going to be working on is free of small wires, metal pieces, anything that could stick to the board and cause a short across some of the traces. So we're going to start on the assembly section. So here's the board. As you can see, a picture of it. I just want to say as well that this assembly manual is very detailed. And so I'm again only going to highlight sections that might be new for you. And so you're going to be working on finishing each of these sections on your own. But the manual is very detailed, so please be sure to read all of the text to make sure you're comprehending it in the way that I'm going to describe it. I would, on one of the last pages of this manual, there is another schematic, and you should pull that out, because as we're going through, just like we did on the inventory, I'm going to highlight each of these components as I solder them. And again, if you did not go back to do the very first lesson, then this is what the result will be. And this is whenever we have already inventoried all of our components. So I'm going to start here with the resistor section, and we have R1, it's 100K. So I've pulled that off of the inventory and I have the component. And now I want to find this on our schematic. It is here. Okay, and then I'm also going to find it on our board. And it is here. So let me zoom in. And because I'm about to solder R1, I'll solder it first and then I will go back and highlight it. So you might have received one of these. This is a lead bender. You can use this, but you can also use pliers, or if you do it carefully with your fingers. So you'll need to match up which size you want to bend it for. I'm going to try this particular size and see if it's the right one. This is way bigger, so I'm going to bend it back and try a much smaller size. I suspect it's going to be one of, like, maybe this one. Okay, that looks to be about right. Whenever you push this down, this should be flush. And this was covered also in the through hole soldering lesson. So again, if you did not do that lesson, please go back and repeat, start there and then come back to this, or else you're going to be confused with what we're doing. Okay, so once you push it in, it should be flush, and then you can take out the two leads. You're going to bend them out, and then we're going to solder that. So to go over soldering again, you have your solder iron, and remember, I've got the solder on and it is very hot. So I want to be, again, very careful of not putting my other hand in the way of the soldering tip. It will burn me severely. So please be very careful with this. My soldering iron is at 650 degrees Fahrenheit. So I have the solder. I'll come through again, put some pressure here, hold it, heat it up, and then I'm just pushing the solder through to flow it. And it doesn't need to be a whole lot, just a little bit. And then I will do the other side. All right. So that's what it should look like. And then you can see it's pretty flush. And then the back looks like that. And now I'm going to take my pliers. Excuse me, these are my cutters. And I'm going to face this away from my face and cut. And I'll do the same with this one. Again, I'm not cutting perfectly flush on the board, so there's still a little bit sticking up here. That's how we want it. Okay, so now that I've completed that one, I'm going to highlight R1. And also here, I'm going to check off our box. Is that enough?
And then I would say,
Yeah.
so, and I'm just going to repeat this for all of the resistors.
Okay. So after I've checked this off, then I'm going to repeat soldering. So this one we're not going to install, but all of the rest of them will go through and I'll install on the board and check it off. So this should be where you should continue on. Okay, so we're now going to skip ahead into the capacitor section so you can see how to solder those. So previously we've discussed capacitors and how some of them are polarized and some of them are not. And polarized means whenever we're soldering that there is a special orientation that the capacitor needs to be placed onto the board. The board should have a indicator on the silk screen that is going to tell us what the polarity should be, where the positive side and where the negative side should go. And earlier, we went through C3 through C7. These were not polarized. So you won't see any positive or negative indicator on those, and you can solder those in directly without without really taking care for the orientation. However, C1 is polarized, and there's a section here, so please read that. That you will need to pay attention to it. When we are looking at this board, we can see the different capacitors. So there is C1. This is the one that's polarized, and there is a plus here. We also have, you can see C3, C4, so forth, C6. You can see that there isn't a polarity, there isn't a plus or minus on here. So those can be installed either way. So I'm going to go ahead and install C1 so we can see, go back through that and be reminded about how that would work. So I'm going to pull C1 off here. It's going to be the larger capacitor. So when I take a look at this, there's two things. You see on the capacitor that there's a marking here. It's a gray area. That's a different color. And then we also have two different lead sizes. So there's a longer one and a shorter one. So the longer one is plus side. The shorter is negative side. We're going to see that again with the LEDs and the LEDs. And then this is also, this stripe here is also indicating the negative. So same principle as the resistors. We want to make sure though this time we have the plus. So the longer lead is going to the plus side, and then the negative is going to the opposite side. So again, we want to get this flush, put it in, bend the leads, and now I'm going to solder that. Same concept as before. I'm going to trim this away from my face. Okay. So you might ask yourself, what will happen if you put this in incorrectly? And what can happen is that eventually the capacitor will become damaged, and it might actually, there's different failure modes. I'm not exactly sure. The first thing is that it's not going to work anymore. The second, I don't know how it's going to fail. It might even short across it, or it might become an open circuit, which would be particularly bad if it short circuited. I know that these things can also get like physically damaged, so it might get really hot. So you definitely want to take care to put these capacitors in correctly. So again, I've just installed a component. I'm gonna go to the manual. I'm gonna do a check here, and then I'm also gonna go to our schematic now and find where C1 is, which is, let's see, C1 is here. And I'm going to mark this off. Okay, so now we've got those components done. And just to show you how to do this, I'm also going to go ahead and solder in one of these four. So these are all the same value for C3, C4, C6, and C7. So we're kind of working on the top section here. So I'll go ahead and install C3 just to show you. So this is a pretty small component. So I'm just going to take it, and it actually, this will fit in perfectly as it's already done. So you don't have to bend it. It's really nice. So this particular one, it is already bent perfectly for the holes that you're going to have on the board. You might have one that you have to bend slightly, and that's okay if that's what you have to do. And oftentimes you see that these won't sit maybe perfectly flush, and that's okay too. You want to get it down, where you can, but you want to make sure that there's not any stress on any of the components whenever you're bending the leads to make it fit. So again, same thing. I come through, bend the leads out. And I'm soldering here. Okay. I will check this off. C3. I'm going to highlight C3. C6, C7, C2, C4, by the speaker. Awesome. C3 is here. So please work on all of the other capacitors, and I'm going to skip ahead to the next components. There are pictures in the manual that tell you how far you should be as you're soldering all these components. And we're going to move on to the section that says semiconductor. So there are two transistors, Q1 and Q2, and we're going to work on those. So in the last video, when we did the inventory, I mentioned that there are two different part numbers for the transistors. So it's really important for you to pay attention to this. One of them is an NPN transistor and the other is an N-channel junction field effect transistor. Here are the components. One important point that I want to mention is that my board is not populated in the way that your board should be at this level. So please refer to the manual and those pictures that should tell you your board should match what is in the pictures in the manual and not what you see here. Again, I'm just highlighting specific areas that you, different components that you need to have special care when soldering. So I have two of the, here are my two transistors. I'm going to pay very close attention right now to which one goes where. So let's go back to the manual. Q1 is going to be the 2N3904. That is here in your schematic. And then on the board itself, it is, there's Q2. So that's the second one. And let me find Q. Oh, it's right here. Here's Q1. So it's kind of hidden. You can see the designator. It's slightly hidden. So there's also a flat section and a curved section. So whenever you're looking at these components, you want to make sure you install this correctly. So as I'm looking at these two different parts, I see one says MPF 102. The other one says the 2N3904. Hard for me to read. All right, so I put because I'm doing Q1, I put the MPF 102 back into my foam case, and I'm just going to use this one. So whenever you look at it, there's a flat section and there's a curved section. So I like to spread these apart a little bit. This does not have to be flush perfectly. It can stick out a little bit from the board. So you definitely do not want to bend the leads to stress these parts. So you just really need to get the spacing enough to where the leads are spaced out enough to be able to push it down, and then you'll have this little gap. On the back side, I tend to put a finger on it on this side, and then I can go through and just slightly bend the leads here. Same as before with the soldering. That's what it looks like. And then same concept, cut away. So please repeat this with the second transistor for Q2. And again, I'm gonna check this off and then I'm going to highlight Q1. So you'll work on Q2 and then we're gonna go to the diode right now. So that's D1. We have it labeled. So a diode is also polarized, but this device does not get damaged like a capacitor if you put it in incorrectly. But what will happen is current will not flow through the diode, and therefore your whatever this diode is supposed to do in the circuit, it basically will cause an open circuit. So it's certainly something that's not dangerous, but it's something that will just cause your circuit to not work. So pay attention to it. There is, hopefully you can see it. Let's see if I can get focus. One side of this has a silver marking around it. That is the negative side. And then this other side is the positive side. There's not really any difference in the lead size, so you can't use that. You just have to know that the negative side corresponds to the marking. So I kind of think of that marking as like a negative, just a negative symbol. So on here we have D1, it's right here. And you can use the lead bender for this. So I just talked to you about this negative indicator. You can see on the silk screen, you'll see a line going across. So you kind of see a box and then there's a line that divides two sections. That is the negative indicator for a diode. So you'll put this in and then it just looks just like a resistor whenever you're soldering it. I'm going to check this off. I'm going to highlight this. Okay, we're going to move on to the LED. This is D2. So last time we discussed LEDs and talked about these are polarized. Again, these are polarized in the same way. It's basically a diode. It just emits light. So this had also kind of like the capacitor. It has a longer lead for the positive and then a shorter lead for the negative is how I usually look at this. Again, unlike the capacitor, if you put this in incorrectly, it just isn't going to light up. So let me find the LED. Oh, sorry. So it's D2. Okay, so there's also a flat section of the LED on the actual component body. And be a little bit. When I take a look at this, I know that this long side is a positive lead and then the shorter side is the negative lead. And we discussed this last time that there also is a flat side to the LED. And when I'm looking at this LED, I'm really struggling to see the flat side. And the flat, wherever the flat side is, they will have it indicated on the board here, so we could use that. But because I'm struggling to see this, I'm going to go back to the schematic and see if I can figure out where the positive and the negative should be connected to, so I can figure it out on here. So when I take a look at the schematic, I have D2 is here, and I can see that so this is the positive side and this is the negative side. Whenever I look at a diode, I always kind of know that when I look at the schematic symbol, because we have this line across here, that typically indicates a negative. So the positive side should be connected to one end of R3, and then the negative side should be connected to one end of R5. So these are the ways that we can figure out. And whenever we come over here on our board, we can look at these traces. So when I follow this trace right here, I can see that it goes underneath this diode, and then it looks like it comes over here to R5. And then if I were to try to verify the other side, I'm going to flip it around and find out that this is the other trace. It's on the bottom side of the board. And when I trace it out, it comes down here. And it turns out that that is in fact R3. Okay, so again, what we just learned is this is the side that's connected to R5, and this is the side that's connected to R3. When I come back to my schematic, I say, oh, the positive side, which is the longer lead, should be connected to the square hole, and this will be connected to the circular one. So here's the longer side. I'm going to put that in this way. All right. So this page should be completed other than the extra work that you're going to do with Q2. We're going to move on to the IC socket. This is something we did in the previous tutorial, but we'll go through it again. So important points is when I go to solder this socket, we're here. There is the notch that we talked about pretty extensively last time. So I'm going to identify that notch, and that notch is going to help me identify the pin 1 indicator on the board. And so on the board, when we're looking at this, I can see there's a notch there, and there's also a pin 1 indicator, and also the hole itself. If you look at it very closely, you'll see that it's actually a square and not a circle. So all of those tell me that that's where pin 1 is supposed to be. And it's real important that I line this up. So when I'm doing this, because I've already put this capacitor in, I'm going to be real careful and not just shove this down onto the table. I have my finger on the back side of this, and I'm going to ensure that my finger is on the side that I'm not going to solder. So it needs to be the opposite corner. And you come through. It's a little hard to do this without a vise. Normally I would have a vise to do this. But I'm going to just solder pin 1 right now. So I just get that single pin done. Now I'm going to take this board and I'm going to flip it back over. I'm going to look and I'm going to say, did I get that flush? And it looks like it is pretty flush. So that's good. And again, whenever you're resting this down, be very careful of that capacitor or any other components that are sticking up. So now that I've got that side down, I'm going to go ahead and do the opposite corner. Okay, again, I'm just doing 2 pins and I'm gonna take a look. The reason why I only solder 2 pins at first and look is because if you solder more than that, then it becomes incredibly difficult to remove this device and you're pretty much locked into place. So you want to check it's flush, and you also want to check one more time that you've got the pin 1 indicator correctly. And so once I get all that squared away, then I'm just going to go through and actually solder this. All right. So that's what it should look like in the end. Check this off and then come here and so this chip is divided on the schematic into 2 different areas. So there's basically 2 circuits within 1 chip. And so when I look at the pinout, I can see here that it like this section over here has pin 1, 5, 14, 7, 3, 4, and so forth. And then this one here is the other pins of that chip. So whenever you add this all together, you should get 14 pins whenever you go through. So that's why you will see that. So I'll just go ahead and kind of highlight both of these for now. The other important thing that's missing is the actual IC chip, and we'll add that afterward later on. Do not add it right now. So the next section is J1 connector, and we are not going to install J1 right now. It's for an external radio. We're not going to use that for this exercise. We're going to move on now to the battery holder. So this is going to involve not only the battery holder, but also the 256 machine screws and nuts. So looking at this is the battery holder, and there are 2 pins. That's going to be the pins that we're going to solder. So you can only put it on the board one way in order to get those pins through. And then we're going to need to put our nuts through here, screws, excuse me. So just simply, you'll put the outer head facing that way, and so ultimately to do this, you're going to need a Phillips screwdriver. So I have one here, just simply tighten it. Oftentimes, whenever you're tightening screws, it's best to put them all in loosely and then go back and do a final tighten after you get everything in. Otherwise, it's inevitable that you're going to have tightened it too tight and the holes won't line up anymore. Yeah. So install the 3rd screw and nut, and then we're going to solder it after you install it. This is going to require a little bit more solder than what you have been using. So just kind of be patient as far as heating up the pin. You might need a little bit extra time to heat it up than what you've done with the capacitors and the other components, resistors and the IC chip. So you want to definitely get a good amount on there, but not too much either. And again, I like to go back and touch up sometimes some of the solder joints. So afterwards, it should look like this. Focus it. On the battery holder, note that these are sticking out further, and typically these are not trimmed. So you do not need to trim this. Just keep it like that. When I look at the schematic, the battery is up here, but it's important to note that this is only a symbol for a battery and not a battery holder. So this is just +9 volts. Again, it's polarized whenever you see the schematic symbol, as well as what was on the board. But because we used a battery holder, the orientation of the battery holder was the way that we were able to get the polarity right. So you can just simply highlight that section for this. So next we're going to work on the speaker. This is what the speaker looks like. And you can see on the board itself, this is also showing a plus symbol for it being polarized. So again, this is one you need to pay attention to. And you can see there's a plus here, and that does actually correspond to that lead, but you can also take a look. This particular component has a plus and a minus also on the bottom side. So you can take a look at there either way. So I'm gonna go ahead and put this in. So because I have the other components in, I'm gonna have to use my fingers to hold on to the bottom side. It might be a little tricky to do. So I'm gonna do just one side, and I'm checking again to make sure that it's actually flush. And it is. So now I can do the second side. I kind of let it cool, and then I just go back and touch up the first side. Again, the symbol is just kind of a speaker. Okay, in the next section, there's going to be two different things. There's a thermistor and a light sensor, a light sensitive resistor. So first, we're going to work on the light sensitive resistor. But before that, this is going to be the card that you have, and there's going to be the thermistors. There's two different types, and then there's also the photocell. So we send these out with options for both of them. So you can just choose whichever one you would like for both sets, the photosensitive resistor as well as the thermistor. So just you'll pick each of these, but take a note in your notebook which one you chose, so you can again go back and put that in your report, which one it was. And then also you can refer to the actual data sheet so you can understand how they work. So we're going to start with the photocell, and that is this one here. So I'm just going to choose this, the smaller one. So let's take a look real quick at the light sensitive resistor. So there's a couple diagrams here, and you can see how we're going to put the heat shrink onto the leads before soldering it. So, and the reason that this isn't flush against the board is because you really want to get it above these other components. That way you're not blocking any of the light. So you don't want it to be too far, but it's probably a 1/2 inch above the board. So for this, I'm going to use some heat shrink. So if you have some, find a smaller diameter that can fit over the leads. And I'm going to use my cutters. A lot of times when I do heat shrink, I do like to use just regular scissors to make it a solid connection. Oh, and I've got scissors here. So I would recommend using the scissors rather than the cutter. And I'm just going to cut off a small section. And then I'm going to match up the heat shrink to make it match. So you want 2 pieces that match decently. I will put those on. Okay, so once you put the heat shrink on, now you can go ahead and put this into the board. And one note here is that we can see there's no indicator that this is a polarized component, and it's a resistor, so those typically are not polarized. So you can just go ahead and put this in, and you might want to just make sure you're not putting any pressure on any of the leads. So you put this on, and then you can go ahead and bend the leads, and we're going to solder it. So again, I haven't heated the heat shrink yet. It's probably the easiest to do it this way. Okay, and then this is what it will look like. And then we can take the heat gun. So this is what our heat gun looks like. Yours might look slightly different. You can turn this on. It's kind of like a hair dryer if you've ever used one at your house, but it blows much hotter air. And that means that if you put your hand in there under it, or you touch something after you've heated it, it can burn you. So it's important for you to be very careful with it whenever you heat the heat shrink. Okay, so whenever I'm going to use the heat gun, I'm just going to heat it up very quickly. And what I'm looking for is for the heat shrink to basically shrink and get tight around the leads. That's all. We don't need to heat it up any more than that. That's the whole purpose. Okay, and that is it. So the reason that we're using heat shrink and what it's doing after we're using the heat gun on it is the heat gun is simply just shrinking the material so that it has a tight fit around the leads. But the reason also that you would use heat shrink, and you can use it for this application, but there's plenty of other times with wires that it's good to use heat shrink, is because it electrically isolates the 2 different leads from each other. So that's really important, and that's the way that heat shrink should be used. So we're gonna go ahead and check off the light sensitive resistor, and then on the schematic, it's here. Okay, so now for the thermistor. So for the thermistor, we are going to need to solder another wire. And there's a couple different important things here. So first is you need to pick one of these 2 parts. You need to take note of it again. And if you were to have a crimper for what's described in the manual, some people might have that. then you would need to solder in this header that you may have, and you would crimp the wires into this connector. Okay, so that's one way you can do it, and then you simply plug it in. But the other way, if you don't have this, is we're going to solder directly. Okay, so I'm going to go ahead and so in either configuration where we're going to solder directly to the board or you're going to use the crimper, you still have to solder these wires onto another wire, which can be kind of tricky. So just to be aware, whichever method you want to try, it's fine. One important note about whenever we're soldering the other wires to it is that this thermistor is going to eventually go into some form of liquid for you to be able to calibrate the thermistor. And when we're doing that, you will normally not want to put the board, you'll never want to put the board into water. So we're going to just dip only the thermistor into the water that we're going to be using. So we want the wires that we're going to make that are going to attach to here to be about 1.5 to 2 feet. So it's really important to cut the wires properly. So I'm going to show you how to go ahead and cut our wires. So I happen to have 2 different colors. If you can use, because in this particular instance, it doesn't matter. It's not polarized. You can use 2 colors or you can just use the same color. It's fine. Often if you're using power, then it's really nice to use different colors. Like you would use black for ground, and then you would use like maybe red or white or something for positive voltage. But in this case, it doesn't really matter. Okay, so I'm going to get about 2 feet of wire. I need 2 wires. So it's important to cut each of them to be about the same length. Okay, so I have the 2 wires here. So this wire says 24 gauge. We went over this last time about how to use the wire stripper. So I can find right here 24 and do that, but instead what I'm going to do is go ahead and start on the lowest one, because I just want to make sure that I can strip this without nicking any wires. A lot of times when you go straight to that particular wire gauge, the insulation might be different. So I like to start on a larger one. So for me, it looks like the 20 or 22 is the proper one to use. So I just want to strip, you know, a fairly small section. So when thinking about how long to strip the wire, take a look at how long these leads are. So we're going to eventually need to kind of thread these 2 wires together. So you probably want to get a decent amount stripped here. Okay, and I'm going to go ahead and do that for the other one. This is going to be, I'm stripping right now the one that's going to attach to the thermistor. And then on the other side, I'm going to go ahead and do a shorter strip so that we can go to the board. So this is for the other end of the board. Okay, there we are. And we're going to work on the section to attach to the thermistor. So we have the stripped wires, and then we have our card. And there's several ways to make the connection. But since I already have a piece of tape right here that's holding this down, I'm gonna fold these up, and then I'm just gonna use this piece of tape to attach it. So if you've already taken it off of there, it's okay. You can maybe put it back on and put the tape back there so you can hold it in place. So then I'm gonna take this wire, and I may have to actually strip it a little bit further back. So right now I'm just twisting these wires together, and it's pretty difficult. So if you're having problems with it, it's okay. It might take a few times. You might also be able to use your pliers to do this. In fact, I think that's what I'm going to do. Okay, so now that they're together, I can come through and solder this. I'm going to be real careful not to touch the soldering iron to the paper. Okay. And I'll see, how good this connection is whenever I get done with this. And if I don't feel good about it, then I suggest, redo it, cut it, strip it again, because if you don't have a very solid connection here, then it could definitely, it'll just break. It won't work. So right now I'm gonna go ahead and use some tape to just tape down this other wire, the wire that we just did. That way it doesn't flop in my way when I'm working on the second one. And I want to note right here that I actually don't exactly like the way that I made this connection. And so we're going to see what I'm going to do with the next one in order to improve this. So the reason I don't like it is because I've come in with this blue one right in the center, but ideally the blue insulation should start at the very end and then it should be wrapped around. So let me show you how to do that. A lot of times it takes practice to be able to do this. And, that's one nice thing also is that you do have two thermistors. So if you do end up struggling with this, then you can use the second one. Okay. So hopefully you can see that now the second one is more, the two are interlocked together. This is definitely a preferred method. Okay. And I'm actually going to go back and see if I can maybe fix this one. All right, so I'm gonna go back and fix this, and you can have however you want to do this in the video. This is so difficult. It's non-flexible at this point. I do not like it. It's just completely inflexible. Okay. So I have the wire, the thermistor together now, soldered together, and there's a few things. So we're going to be eventually, like I mentioned before, this is going to be dipped in water. And so we have to waterproof our device. One option to do this would be to use heat shrink. Like I would, if this were a regular cable, I would never leave uncovered leads like this because it's just very simple for these to eventually touch together. And once they short together, then that's a short across our circuit. So you could potentially use heat shrink if you had that. And this is too small. So if I had a piece of heat shrink, you could go across and you want to definitely put the heat shrink on before you solder to the board. Once you solder to the board, then you can't put heat shrink on any longer because you basically cannot access the leads individually. So this is one way that I would cover this one, and then I would cover this one with heat shrink. I would use the heat gun and shrink this over these wires, and then you would basically be able to insulate these two exposed connections. So after I would cover both of these, then I would use a larger piece of heat shrink and go over both of these smaller pieces, and that way it could fully secure it together. So that's typically how we would make a cable where we're doing this, where this is called splicing wires together. But it is very likely that you have access to something called the liquid tape, liquid electrical tape. And so I'm going to show you that method right now of how to use this. So the electrical liquid tape, you're going to need to let that dry for an extended period of time. So probably let it sit overnight. So we're going to show you how to apply this. Let's pull it off of this card. So for the liquid electrical tape, you want to get something that you definitely do not want to use the liquid over your ESD mat. So you want to have some protection. This is just some other little board. You probably want something thicker than a piece of paper as well, because it can be thick, so it might leave it might bleed through the paper. So try to find a piece of cardboard that you could potentially use. So I've already had one spot where we've used this. So whenever you put this down, we want to tape this so that the leads are not touching. So I don't want to tape it where I'm going to actually use the liquid. I'm going to tape it in the back. Again, making sure those points are separated. So the consistency is basically like rubber, and you're just gonna apply uniformly across it, and you're gonna see it's a little bit, it's going to be kind of sticky. Make sure to try to not get your hands in there, and just kind of apply it as you feel you need to across the leads. And so whenever you're doing this, use as much as you need to, and don't worry about the extra that is going to be on there, because you can cut it off whenever it dries. And so you'll just basically let that sit overnight. So I'm going to show you how to solder the other ends of the board. So we're going to be soldering our thermistor to this this area here that's labeled thermistor. And one kind of thing that you see is we just solder to 2 wires, right? But yet there's 3 holes here. So which one do should you solder to? And if you take a look at the back, you can see that it turns out that the 2 end pieces are exactly going to the same spot, while the middle one will need to solder. So you need to solder to the center one and one of the 2 ends. It doesn't matter which one. You just need to pick one of the 2 ends, center and one of the 2 ends. So here are the 2 different leads that we have. And one of the things that I like to do before I solder something like this, it's not 100% necessary, but a lot of times it does help to make it just easier to slide this in, is I just put a little bit of solder onto this wire. And this is just keeping all of the strands completely intact. Okay. And then I'm just going to choose this outer side for one of the wires. So you'll probably have to put some force on it to keep it in. And then this next one is just going to go in the center. And then you can trim this if you feel like it's sticking out too far. All right. All right, and so check that off. So now we're completed with assembling all of the parts. And you're gonna, before, with the exception, we have not installed the IC chip. And so now you're gonna work on these initial checks with these different resistances. All right, so whenever you get to the resistance check, you're going to connect the negative lead of your multimeter to the negative terminal of the battery holder, and then you're going to probe the following points. So you're going to go to pin U1, and then you're going to verify that that's going to be the positive lead. Again, the negative lead is on the ground, and then you're going to verify that it's going to be over 100K. And then you'll move on to each of these, and you're going to write down the measured value that you have. So whenever you write these measured values down, just to note, it's not going to be exact, and that has to do with that 5% tolerance that we talked about on the resistors. So it should be pretty close. After that, you're going to go to the voltage checks. So this is the 9-volt battery, and you're going to need, this is polarized. There is a plus and a minus side. And the way that you tell on the battery holder, if you look very close, inside here, there is going to be a plus sign here and a minus sign here. So you can see it, it's written kind of on the holder. It's an engraving. So when you go to plug in the battery, it tells you what the positive and negative polarity is based on the shape of the this connector. So the negative side is over here. So I'm going to face it like this and then slide it in. And now I'm going to run through the voltage check section, which is here. And again, go through each pin, follow the directions, and measure the expected value measure the value, and it should be in the range of what the expected is. So something important to note is this is telling you that it's 9 volts, but the battery itself may have been previously used. So this is kind of like a nominal value. You might have something that is in the range of 8 volts, depending on what, the voltage level of the battery, but that is the voltage. When you're seeing 9 volts here, that's just the voltage of the battery, which you can also take the battery off by itself and just measure that voltage with the multimeter, and that should match all of these values that you're seeing on the circuit. So the very last thing you want to do is you're going to then remove the battery. Very important to remove the battery before you install the IC chip. So this is the chip that you're going to install. Should be the last thing left in your inventory. And it's important to note here so this notch corresponds to this notch here. And so that's the way you're going to install it. And so it can be a little tricky to install these. So please pay attention whenever you do it. First off, you need to ensure that as you're putting it down, that each of these leads properly match up to the hole. If it's off center and then you push down, you're just going to bend the lead, and it actually will never make connection with the pin itself. So what I like to do is get one side in and verify that all the pins are touching, and then I kind of go to push the second side in, but I use my fingers just a little bit. I know it's hard to see this, but I push down on the opposite side to make sure that all of the pins are properly in every hole, and there's not anything that is is missing. And then once I verify that, then I push it down completely. And now whenever I reinstall the battery, as soon as you install it, you should hear this LED should be flashing, and we should hear a beeping noise. So this light sensor, when I cover this is going to change the speed at which the beep is occurring. And then the temperature sensor is going to change the pitch of the beep. And so you can actually come in and I'm just holding the temperature sensor right now, and you should start to hear a different pitch. And that's how your circuit should work in the end. So if you get to this point and it does not work, then the problem most likely is you have a bad solder connection, or you have installed one of these components incorrectly, backwards. It wasn't polarized. So you need to go back and verify all of the polarity of the components, like the diode, like the capacitor, like these transistors, the pin 1 indicator on the IC chip. These are all in the speaker as well. Those are all important components that you might have installed incorrectly. Oftentimes, whenever you go and look at the back of this, it may be the case that you forgot to solder one of these pins, or that it wasn't soldered well, it wasn't actually making a very good electrical connection. So one of the things I like to do if something's not really working is I come back and I retouch up. If you look at it and there's not anything obvious, just come back and retouch up some of these solder connections. You simply just put the soldering on here and let it heat up, and you might come back in and add a little bit of solder just to make sure that you did a good job of heating up each of those pins. So those are things you should check for. You also need to ensure that these pins are all going into a proper socket. They're not bent. That can also be one of your problems. Let's say that you go back through and there's nothing obvious to why you're having a problem. Then what I would recommend is to go back to the initial test check. So go ahead and you can remove the integrated circuit chip. When you remove this, be very, very careful to not bend the lead. So I'll show you how to remove that in a second. But you can go back through and do all of these resistance checks. And then if you see something is not quite the right value, then use the schematic and go back and see where does pin U1 go to? Well, I checked U1. Okay, that was not the right value. Then I see what it's connected to. I see it's connected to R4. I see it's connected to the, this light sensor. So go back and check those solder connections. Is there a problem with that? So you basically want to use this schematic in order to kind of retrace what the problem could be. But you have to pinpoint it first to know where to look, other than just doing a visual check. So whenever you remove the IC chip, I just want to show you this. Sometimes it's best to get a flathead screwdriver. This is a flathead screwdriver. And I like to just pry up this a little bit at each side. If you just come in and you pull this up, it's inevitable that some of the leads are going to get bent. So I like to come over here and I just kind of gently pull up on this one side, and then I work my way on the other side. And I'm very gentle with this. I'm going to be very, very careful. So you just want to slowly lift up on it. Slowly lift up on the other side. Slowly lift up on this side. And then we're going to go back. And now once I kind of have it up, then I can pull it out. And then you can see that all of the leads look pretty nice. There's one lead here. I can see that's bent, so I need to be careful when I come back in. But otherwise, that's how you pull that off.